Welcome to our lecture online. Now let's find out where the equations came from that depend on the time, the position, the velocity, and the acceleration as a function of time. So here again we have the same kind of setup. We have a spring, we have a mass, we pull on the spring this time. Instead of compressing it, we elongate it, and at time equals 0 we let go. Alright, we again use the equation of Newton's second law and the force restoring equation on the spring, and we set those equal to each other. Then we bring the minus kx over to the left, divide both sides by the mass, and we end up with this equation right here. Now we replace acceleration by the second derivative of the position with respect to time. And now we also take k over m and replace that by omega squared because of this relationship right here. And now what we have is a differential equation. And the solution to that differential equation will either be this equation or this equation. And again, the equation you pick depends on the initial conditions. Now notice, if you think, well, where did that equation come from? Just to make sure you realize that these are indeed solutions, go ahead and plug x in here and take the second derivative of this equation, plug it in here, and you'll see the left side equals the right side. Or you can take the second equation, do the same thing, and again the left side will equal the right side, which shows that those are indeed solutions to that differential equation. Now in this particular case, notice when time equals 0, the object is at the maximum positive distance away from the equilibrium point. Well, that means that the function we use, the equation we use, must be at its maximum value when time equals 0. Well, here, when we plug in 0 for time, the cosine of 0 is 1. Therefore, 1 times a will be the position of the object. So in this particular case, that means that this would be the correct equation to be used and not that one. If, for example, the object was at the equilibrium point moving to the right, then we will pick this equation. If it's anywhere else, well, we'll get to that. We have a video ready for you that will show you which equation to pick depending upon what the initial conditions are, but it'll be something in the form of the sine or cosine, and that is how it's done.